Hello everyone, welcome back. And today we're gonna cover all the rest of the chapter 3 and give you guys a short summary. Then for next video, we will move on to the polynomial, okay? And for this one, again, actually we did cover it in previous videos about using matrix for transformations, but I think it's a good recall, to refresh you guys' memory. Just make sure if we're doing the matrix for transformations, our image always on the left hand side, and this is our transformation matrix, and this is our original point or coordinates plus something like the translation. Okay, so this one and this one, A and B, are the important part. Okay, and let's just give you guys some example to emphasize my point. So for example, let's look at this guy. Find the image of the point, okay, and the reflection in the x-axis, so which means xy. Reflecting x, we change y, right? So becomes x negative y, and then followed by the dilation of factor k from y. From y, we change x, so it's kx negative y, which means that x dash equal to kx and y dash equal to negative y, okay? So I write x dash and y dash over here, and I need to figure out this matrix and my xy over here. So because x dash is equal to the kx, so it's just like k0 over here, because k times x and plus 0 times y, okay? And my y dash is negative y, so it's just 0 and negative 1, okay? So that is what we want, okay? We don't need these two steps, okay? It's harder. We can just use one steps to directly show, right? So the initial point is 2 and negative 3. So we plug in, okay, plug in here. Then we get our final answer is 2k and 3, okay? That's example 22. Let's move on a little bit. Also, if we look at example 23, this is a bit harder because, as I mentioned earlier in chapter 2, it's a literal. So basically, it's just use letters to represent the arbitrary constant and to do the calculation. So sometimes it's really confusing because you cannot really distinguish what's the difference between x and y, which are variables, and what is the arbitrary constants, which a and b in this case, okay? But make sure you guys try this question by yourself and to see if you can get the answers, okay? And again, we can use a matrix to do the transformation of graphs, right? So essentially, it's just like finding this, okay? Again, just this is actually what we want, okay? So once we have this relation, which is a coordinate method, we have it before, then we plug back in our original equations, then we can get our new transformation equations, okay? So that's pretty much about it. And if we look at 25, it's the same thing, okay? But just make sure sometimes in this one, actually we do what? We do translation first, okay? Then dilation factor, okay? Normally, I know it's a Dr. T, right? But sometimes the question just try to trick you, so they will do the translation first, then do the dilation. So it really depends on the problem. But when we doing the calculations, we always follow by DRT, okay? Just to make sure you follow this way. And it's just can easier for the examiners and the markers, to follow your each step, okay? So let's keep going. Again, for this one, this is the way the exams just gonna show, like the transformations. So this means the dash and dash. And some people can ask me, so what does it mean by r square or something? It just means x belongs to r and y belongs to r. So we use the shortcut way, means r square. So it's two-dimension things. And again, approach or point to r square. So basically, for our new point or our new graph, still in the range or in the domain of R, not the complex. So this one is not that important, but you just need to know this, okay? Again, let this one be the x dash y dash, so we get this one. Then we got this essential relationship, then rearrange, plug back to get the overall values, okay? This is what the strategy or what the logical sequence steps we do for these types of problems, okay? And let's move on to this one, section summary. You don't need to remember, just make sure you can write rules, then it's easy to write the matrix, okay? And the final one is using the inverse 2x2 matrix for transformations. This one is essentially similar as before, but they just make it organized and introduce you some new concept. Okay, first inverse functions, inverse matrix, and for math method we only do 2x2. Okay, and for the matrix determinant is AD minus BC. Okay, so if the matrix got an inverse, it has to be determinant not equal to 0. Otherwise, 1/0 is not exist. So not every matrix got the inverse, right? So if it's not, then we just call it singular. Okay? And let's keep going. We will see why this is the case. And we can clearly see that if we want to get our xy from in relationship with x dash y dash, we just times the inverse over here. So we directly get this one. Sometimes you can see, so I have no idea how to do it, but then if we don't use this method, I still can use this one to get x dash equals 3x and my y dash equals 2y, right? So essentially, this inverse function just help us to do this step. So become x dash equal 1/3 x and my y equals half y dash. Okay, so it means the inverse function just help us to get or help us to make our xy be the subject again. Instead of old-fashioned way, we were doing the x dash and y dash. Okay, but sometimes if you feel it's a bit hard to remember or to do the inverse, then just use the old way. We again get this one first, then rearrange to get this one. So it's the same thing. Okay, so for this method, if you think it's easy to understand, just use this one. If not, then just use the old way. Okay, that's pretty much about it. 3J, and let's look at the chapter 3 summaries. So basically, for final year exams in transformations, if it's in exam 2 and it's a big question like 3 marks, it's not the multiple choice, the highly chance they give you the transformations in the matrix form, okay? And you have to know you can converting this to this and converting back. This is a skill we need use, okay? And again, I'm not really confident or I'm not really want you guys to remember this way because this way is pretty hard and sometimes it's really confusing. So again, my suggestion is use coordinate method to get the transformation graph and rearrange if you need, okay? Because use coordinates method, we can do a lot of following examples such as maybe this one, the really long and tedious transformations, and we can do this one, identify the sequence of transformations, and of course, our multiple choice, and such as this one, and this one, and this one, this one. Okay, remember the last video I showed you guys the 3 linear transformations, and all I used is like coordinate method. So if everyone is familiar with this one, familiar with this method, you can get it. And transformation every time, it tests you guys about 5 marks around. out of 120. So just make sure you guys try the multiple choice, and which is on the page 144, 144, and 145, because this level of difficulty is quite similar to the final year exam. And to see if you can done each of the question under 1 minute and 30 seconds. So this is the requirement time, okay? And hopefully you think this video helpful, and next one we will continue to the new chapter, which is polynomial functions. Okay, if you think my videos is helpful, and please subscribe and click the like button. See you guys in the next videos. Bye bye.